You know, sometimes I can feel really bad for routers. They get put through so many hard, difficult tasks, especially when you're running a light show. You have multiple devices trying to talk to each other and have all this data that needs to be sent through them, and then you have the router there just in the middle that has to deal with all of it. I wonder if all of these devices could talk, what would it be like if two devices were arguing, but the router had to deal with sending all the messages between each other? I am so sick and tired of talking to that Pixel controller today. Router, get over here. What do you want now? I want you to tell that Pixel controller to turn all the lights to be on green. Okay. Pixel controller, turn on the color green. Don't worry, router, I got you. But who cares? Let's talk about how you can take full advantage of this thing. Hey everyone, thanks for watching How To Pixel, and in today's video, we are back with the Light Show Networking with Nick series, and in this episode, we're going to be breaking down another one of the methods you can use to run your light show network. And if you couldn't guess from the title of this video, we're going to be talking about the method where you make a completely separate light show network just for all of your lights, all of your controllers, all of your computers, whatever you need, so it stays away from your home network. Now before we get started, I'm going to give a quick recap on what we've talked about in all of the other episodes for anyone that's new here. But if you've already seen most of the series, then you can skip to this time right here on the screen to get to the tutorial. But basically, this whole series is about how you get all of your light show controllers, computers, any devices you need to run your light display, whether it be for Christmas or Halloween, how we get all of these devices to communicate over a network. Because most of the time, these devices need each other. There's not a lot of times where you only have one device, so you have to learn how to make this whole networking setup, which can sound a little bit complicated, but that's what this whole series is for, so you can watch individual parts about how the grand network works. In the first 3 episodes, we talked about some basic stuff like terminology and networking, and how you can connect to your light show devices to configure them. Then in episode 4, we talked about a whole bunch of different methods you can use to make your devices communicate, and little overviews with each one and the pros and cons involved with the different methods. And then in episode 5, I took one of those methods, which happened to be the bridge method, and I talked about every single detail involved, broke it all down, and made a tutorial for how you can set it up if you want to use that method in your light show. And then for this episode and some of the upcoming episodes, I'm going to pick some methods from that 4th episode and continue to break them down in their own separate video so you can see how to set it up. So if this is your first time tuning into this series and you don't know much about light shows or light show networking, I really recommend going back and checking some of the other episodes just so you can understand some of the things we've been talking about. And I'll put a card up here, I don't know if it's on this side or this side, somewhere. I'll put a card up so you can check out the Light Show Networking with Nick playlist. But yes, in today's episode, we are talking specifically about the entire separate light show network method where you just make a network that's only for the light show. This is probably going to be one of the longer videos of this episode because there is a little bit to it, maybe a lot to it, and I want to make sure to try to cover every detail, that way no one is left confused. So some of this video you might not want to see if you already know how to set up certain parts or you already know how it works. So that's why I have timestamps in the description below and in the scrub bar so you can skip to any part of the video you want to see. But if you aren't familiar with much of this, I recommend sticking through most of the video. So what's involved with this method and how does it work? Well, here is the quick version. So you basically have your home network with your home router. This is what controls all of your devices in your home, like your phones, computers, tablets, whatever you might have connected to it. But then for this method, you take a separate router and plug that router into your main router. Now this new router will create an entirely separate network that we can call the Light Show network. And you can connect all of your light show devices, any computers, any controllers, any device that is just for the light show, you can connect it to this Light Show network. This Light Show network will keep all of the data separate from the main network, and that's a really important thing because there is a lot of data that goes over the network when a light show is running, especially for bigger ones. So keeping it separate from your home network, you really want to try and do that, and that's one of the reasons why this is a really good method. All of the devices on that light show network will also be able to access the internet if they need to. A few examples are for getting the time so it knows when to start the light show, maybe downloading updates, or if you have any plugins that get data from the web, they can do that because it has internet connection. It can go from the light show network to the home network and then out to the internet. And then finally, with a little bit of extra setup, which I'll talk about in this video, you can also get devices on your home network, such as your phones or computers, to access the devices on the light show network. So that's the overview of how this method works. It's sort of like the bridge method, because with the bridge method, you had a device bridging between your home network and then making a separate network. You're basically doing the same thing with this method, except with a router. You do also get a lot more features when you're using a router, such as if your router has Wi-Fi, which most do, you can create a Wi-Fi network for the light show network. So if you have Raspberry Pis running in master or remote mode, you can connect them to the light show network with Wi-Fi. Or if you had an actual computer, like a desktop or a laptop, running software like Xschedule to control your light show, you could also connect that to the light show network. Now you might be wondering, what type of router should I get to control the light show network? Do I need to spend a lot of money to get a good router, or will something cheaper work? So I will say I've only been able to test one router, and it's the only router I've used for my light show network. But this is a very cheap and a very old router. This is the one I used for my light show network. It's from Belkin, if that's Belkin, yeah. Belkin, that's how you say it. This router is from 2011, only has 2.4G Wi-Fi, and I think I wrote it down. It goes up to speeds of 150 megabytes per second. So that's not even really that fast to today's standards with all of our fancy routers today. So this thing is 13 years old, and this is what I tried to use to run the light show network, and it actually did pretty well, I'd say. I'd say the light show worked about 98% of the time. There were a few random times where all the lights would freeze and you'd still hear the music running over the radio, but it probably froze because the data couldn't get through here fast enough to the Pixel controller. Maybe something got clogged, or I don't know. But after about 5 seconds, it'd catch back up with itself. And my light show, I'd say, is a decently sized light show. It has 5,000 lights in it, so a good amount of data going through. And this thing held up pretty well. Now, I wouldn't recommend using a router from 2011 that's almost 15 years old, or however old this thing is. But it does go to show that you don't need anything super expensive. I know places like Amazon sells these little tiny baby routers. I wouldn't recommend those because you want something with at least a few Ethernet ports on it, since you will be connecting Raspberry Pis probably, or computers or controllers into here. So I just recommend doing some research on some routers. I might put a few in the description after I'm done making this video if I find anything, but you don't need anything crazy fast. So now that I've been talking for a while, and you know the basic overview of how this method works, and also how fast of a router to look for, now let's get into the actual tutorial on how to set up the separate light show network method. So the very first step in this method is to hook up your router and get that all set up so we can hook up the devices to the router. Now, plugging it all in isn't too complicated. All you need is just your router. You need a power supply for your router, or an adapter for power. That's what I have right here. And then you also need to hook the Ethernet cable up between this router and your home router. Now, the end that plugs into here, that end of the Ethernet cable needs to go into the WAN port. The WAN port is usually the one that is separated from the rest and is a different color or is in a different area than the rest of the Ethernet ports. And for me on my router, it's this yellow one. Sometimes it might say WAN, sometimes it might say internet, sometimes it might say modem. You want to plug it into that separate Ethernet port. So I'm going to take this and plug that into there just like that. Now this end should be plugged into one of the LAN ports on your home router. The LAN ports are the ones that you usually connect devices to, like computers. There's usually multiple LAN ports, and it doesn't matter which one you plug it into, as long as it is not the WAN port. On my home router, these are the LAN ports right here, and what I have for my setup is I have an Ethernet cable that goes from this LAN port into the attic, and then there is an Ethernet cable jack on my wall over there, and that's where I'll plug this end into, and that'll connect it to the router. So this is now connected to my home router, and now I can apply power to it. So I'm going to plug in the power adapter, and then I'll plug this end into there. I have given this thing and all of my other devices that I'll be using in this video, except for my home router, a factory reset. That way it'll be like you're setting it up from scratch, and that way it'll make sense for everyone else. So now that we have the router hooked up, the next step is going onto its web interface so we can configure all the settings to set it up to be our light show router. Now, if you've seen other episodes in this series, you'll know I've talked about this before, but this step can be the hardest because almost everyone watching, I doubt you're going to be using the exact same router as me. So the router settings could look slightly different, or they could look a lot different than how it looks for my setup. So for this step, you'll just have to follow along the best you can and find the settings on your router. And like I said, they might be in different places. But now, how do we get to the router's web interface to set up everything we need to? Well, it's not that difficult. All you need to do is connect to the Wi-Fi network that the router will make when you first turn it on, as long as your router has Wi-Fi, which I'm assuming it does. Most routers will have a sticker or a label on them somewhere that says the network name and password, and you can connect to it by going onto your computer, searching for that network, and typing in that password. Then after that, all you need to do is open up a browser on your computer and type in the IP address of your router once you're connected to it, and that will open up the web interface. Now, if you don't know the router's default IP address, it might be on the label. For mine, it isn't, so I did have to go look to see what mine is. If you've watched the other episodes, you'll know how you can find your router's IP address. If you haven't, I recommend checking out this episode, or I can't remember what side of the screen it's on. I recommend checking out that video and skipping to this time so you can see how to find your router's IP address. But now let's go take a look at my computer and how to connect to the router, and then all the settings you need to change once you're on it. So I'm here on my computer, and if you come down to my network settings and we click here, you'll see that right now I'm connected to this Wi-Fi network. This is our home network, and this is what I connect to access the internet. But we don't want to be connected to this. We want to connect to the second router we just plugged in so we can access those settings. And this network name right here, this is my second router I just hooked up. I know it is because there's a sticker on my router that says this is the default network name. So I'm going to click this, and then I'm going to click connect, and it's going to ask for the password. And the password, since I just gave the router a factory reset, I'm going to use the one that is underneath the router on the sticker. So I have that typed in, and then I'm going to hit next. And if we give it a second, it should connect to the network. And there we go. It just connected to the network. So now we are connected to the router, and we can go to access it to change the settings. But now I'm going to open up a browser. Any browser works. And I'm going to type in the IP address of the router so we can access it. Now, like I said, if you don't know the IP address of your router and you don't know how to find it, check out that video I linked in this video. But I know my IP address for my router is 192.168.2.1. And if I push enter, and it instantly opens it up. Now, since this is an older router, there are a few things that are a little bit different than newer routers. For example, it gives you a whole bunch of information, and like other things that usually you'd have to type in a password first before you'd be able to see. However, if I click any of the other tabs, it then asks me for the password. The router's password to access any of these settings for me is nothing, so if I just push enter, that will unlock it. For you, there might be an actual password, so you can look up your model and see what the default password is. So once you are connected to your router, there are 3 different things we need to do to get it set up. First is we need to set an actual password for the Wi-Fi network so you can connect to it easier without having to write down that super long default password. Second is we need to change which IP addresses this router gives out to any devices that connect to it. And I'll explain that when we get to that step. And then finally, we need to figure out what IP address this router is using to connect to our main home network's router. First, we'll do the easy setting, and that is changing the password to connect to the Wi-Fi. Now, this is the part, like I said, where it's different for every router. So for you, you're going to have to look for a security tab or one that has all the passwords under it, and that could be in different sections. For me, that is under the wireless section, and then there's the security tab right here. And if we click it, it still asks for a password, but I'm just going to push enter, and it unlocks it. Right here where it says pre-shared key or a PSK, this is basically fancy terminology for the password. So I'm just going to change this to something I will remember, and that'll make it easy for connecting devices if we use Wi-Fi later on. And then for me, I have to hit this apply changes button. For you, it might say save or other things. Now once I click this, it's actually going to log me out of the router, and I won't be able to connect to it again because the password changed. So I need to go back into my network settings and type in the new password. You don't have to change the password, but it just makes things easier. Now the next step, like I was saying, is we have to change which IP addresses the router gives out to any devices that connect to it. Now, why do we need to do this, and what part of the IP address do we need to change? Well, I'm going to assume by now you should hopefully have watched some of the other episodes, so this will make sense. But what we need to change is the subnet that this router is on. If you remember back to the bridge episode, or maybe even to the first episode where I talked about different subnets, the IP address number is made up of 4 groups of numbers, or octets, and each octet does a different thing or represents a different part of the IP address. And the third octet is usually the subnet number, and this kind of identifies which group this IP address belongs to. So for example, my whole entire home network, for all of the devices, the third octet is always 1 because the entire home network is all one group and it doesn't need to be separated. For businesses or other places, sometimes they have different subnets, and the third number can be different for different devices because they have so many devices. The first 2 numbers for our situations are also always the same, and we don't need to mess with those. And then the fourth octet is the host number, and that number uniquely identifies which device is which. So if a device needed to access another device, it would need to know that host number of that device to get to it. So what we need to do is on the router, we need to change that third number, the subnet, because since the light show network is going to be a separate network, we want the subnet to be different from the home network subnet. That way all the data stays separated. What I'm going to do for this video is my home network, like I said, uses the subnet 1. So the third octet is always 1 for the devices that are on the home network. So just to make it simple, I'm going to count up and then go to the number 2. And I'm going to make the subnet be 2 for the light show network. Now you can use any number between 0 and 254 as the subnet, but just make sure it is different from your home network subnet, because if it's the same, then it's not going to keep everything separated. Now the way I have to do this on my router is I have to go under the LAN setup, and then there's this setting called LAN settings. And then under here, it gives you a whole bunch of different settings, but the main thing I'm looking for is the IP address right here. This IP address right here, 192.168.2.1, this is the router's IP address on the light show network. So by changing the third octet of the router, this will make the router give out that same number to any of the other devices that connect to it. We don't need to change the host number because generally you want the host number of a router to always be 1. Now this router actually already comes with the subnet programmed to 2, and that is perfect for my setup because that's what I wanted to set it to. So I don't need to make any changes, but if you had to make a change, you would have to look for some setting that sort of looks like this, and it's the IP address of the router on the light show network. And if I didn't make this clear, this is on the light show router. Make sure you're not changing any settings on your main router. You don't need to adjust anything on there. Now, if I did change something, I would hit the apply changes button, but I didn't need to because the subnet's already correct, the host number is 1, and then the first 2 octets you don't need to change because those are always the same, usually for our small setup since we're not running giant business networks. And then the final thing we need to do while we're on the router, before we go and hook up any devices, is we need to figure out what IP address this router is using to connect to our home network. And let me explain to you what I mean. So what I mean is the router actually has 2 different IP addresses. Sort of like how in the bridge method, the Raspberry Pi had 2 IP addresses. One to connect to the home network, and then the IP address that is the main gateway for the light show network part. Well, the router is basically the same. It has an IP address that it uses to connect to the main home router. That way the home router can know where to send all the data to. And then it has a second IP address, which is the main gateway IP address that it uses on the light show network. In our settings just now, we set up that second IP address, which is for the light show network part. But now we need to figure out what IP address the router uses to connect to the main home network, because when we want to use our devices to access the light show devices, we're going to need to know that IP address. So here are the ways that you can find out what that IP address is. The first way is looking on the light show router, going into the information page or status page or a page that's similar to that on your router, and look for the IP address. Now what you're going to be looking for is the WAN IP. It might also say Internet Service Provider's IP address or ISP, but that's just because this router thinks that it's connected out to the main internet when actually it's just connected to a second router. On my router right here on the status page, you could see that on the internet settings section, it says WAN IP and it shows an IP address right here. And if you look, that third octet in the IP address is 1, which means it belongs to the group 1, and group 1 is our home network devices. So we can confirm that this is the correct IP address that is on the home network side because it is in the home network subnet. Another thing you could do to find the IP address is go on your main home networks router and look there. So if I type in the IP address of my main router, which is 192.168.1.1, and I open it, and then I log in, I can go on the device list and look through the list of devices to find the second router. Now this might be a little hard because it might not be obvious which device is the router. For example, on here there's a bunch of devices that just say network device, network device, network device, and there's not really any information about it. Well, on here, the Lightshow router is actually this device right here, and you can see the IP address of it is 192.168.1.8. I know this is the second router because I already know the IP address, but if I didn't, I wouldn't be able to figure it out that easily since it's not obvious that this is the router. But once you find that IP address, whether using your main home networks router or using the Lightshow router, you're going to want to write that IP address down because we're going to need that for later. So for now, that is all these settings we have to change on the router, and it's all set up now so we can hook up our devices. The next step in this method is connecting up all of the devices that we need to the router, whether it be controllers, Raspberry Pis, anything that's going to be sending data just for the Lightshow. So we're going to be hooking those devices up. And then like with any method, we usually want to set a static IP address for the devices. If you remember from other episodes, when we connect our Raspberry Pis or our Pixel controllers to a network, we go into the network settings and set a static IP address, which is an IP address that will never change. The reason we manually set these IP addresses is because if we let the router do it, sometimes it can change the IP address and then we won't know what it is when we want to go and access the devices. But now let's go see how I have my devices connected up. So it might look like there's a lot going on here, but here's what I'm going to be using for this setup in this example. I have one Raspberry Pi and these two Pixel controllers, and I want to set it up in a way so that the Raspberry Pi can send both of these Pixel controllers data through the router over there. Now, since this Raspberry Pi is going to be sending the data to them and it's not in master or remote mode, I'm going to have to hardwire them. So I have a whole bunch of Ethernet cables here. So I'll plug this controller in first, and then I'll hook up this one into the router. And then finally, I will hook up the Raspberry Pi into the router. Now, the Pixel controllers have two Ethernet ports on them, and that is because you can daisy chain multiple controllers off of one controller. So, for example, I could have the Falcon F16 V3 plugged into the router, and then take an Ethernet cable coming out of the other Ethernet port and have that go into this Pixel controller. They all don't have to be directly connected in. You can daisy chain them if you want. You also don't need to have the exact same model controller. You can daisy chain them with different types of Pixel controllers. But now that these are all hooked up into the router, I'm going to apply power, first with the Raspberry Pi, and then with the Pixel controller. Or Pixel controllers, I should say. And there we go, you can see lights on both of them. Everything is booting up. And instantly, all of these devices are all hooked up to the router. The router went and talked to all of them, and it said, hey, here's an IP address for you, here's an IP address for you, and here's an IP address for you. For some devices, you won't be able to know the IP address at first, because there's no way to tell what it is. But for a lot of Pixel controllers, there are screens on them, so we could take a look at the screens to find the IP addresses. Or you can just log into the router and look on the device list, which is what we're going to do to figure out the IP addresses. So what we need to do is find those IP addresses and log into each device and then tell the device, hey, don't let the router boss you around. This is the IP address I want you to use. And the router will be like, okay, fine, I'll let you use that IP address as long as it isn't in use by other devices. So let's hop onto the computer to see how we can access these devices and change those IP addresses. So first, the computer you're going to be using to change all of these settings, you need to make sure it's still on the Lightshow network. and this computer is right here. So what you're going to want to do is go to your router and look for some type of device list. It might be called DHCP list, might be called client list, device list. On here, on this router, it's called DHCP client list. Now when you click it, it will load for a second, and once it opens, it should show a list of all the different devices you have on your network. So here we can see that we have 4 devices on the router right now. Now this router only shows the devices that are hooked up with DHCP, meaning that they aren't manually set up. So anything we did manually set up, this router won't show, but that's okay. We only have 4 devices on here right now. We have the Falcon F16 V5. We have this desktop right here, which is this computer we're using. And then we have the F16 V3 and then FPP. This right here is the Raspberry Pi. So if we wanted to access any of these devices, minus the computer because it doesn't work that way, we could type in the IP address of the device. So if we wanted to access the F16 V5, its IP address is 192.168.2.3. And you could see that the router put it on the second subnet because that's what we set it up to be on, to go to the subnet 2, which is for the light show network. So let's type in that IP address, 192.168.2.3. This should open the F16 V5, and it does instantly. So starting off with the F16 V5, we're going to set it up to have a static IP address. I'm just going to go over this briefly because I've talked about it in other videos, and it's about the same setup. All you need to do on the controller or computer or Raspberry Pi or whatever you're doing is go to the network settings, and then depending on the device, you're going to have to do some different things. So on the F16 V5, the first thing I'm going to do is immediately disable Wi-Fi because we won't be using it since the data has to be sent over Ethernet. Second is I'm going to uncheck this box that says enable DHCP. We don't want that. We want to set it up manually. So when we unclick that, it lets us set up all these different settings. First is the IP address we want to set it to. The first 3 octets should all be the same because this is all within one network. The 192.168 is always the same, and then the third octet, the number 2, that needs to stay 2 because the light show network's subnet is 2. And then the final octet, which is the host number, we can set this to anything we want between 1 and 254. It just cannot be the same as any other devices, and we also need to remember it. So right now the numbers we cannot use are 192.168.2.2 because that is my computer, 192.168.2.5 because that's the F16 V3, and then 192.168.2.4 because that's the Raspberry Pi. You also cannot use 192.168.1.1 because that's the router's IP address. So with all of that in mind, and now that we know which host number we can pick, I'm going to make it easy and just set it to 100. And then all the devices after this, I'll just count up from 100 because we can go all the way up to 254. The gateway, this is the IP address of the router. This is where the controller will send any data to be routed to other devices. And we know the IP address of our router is 192.168.2.1. Like we talked about in the bridge method, we need to pick the IP address of the router that is on the light show network side, not the IP address that is going to the home network. Because if we put in the home network's IP address of the router, that's not within this subnet, so the controller will try to access it, but it can't because it's not in this subnet. Whereas this IP address is on this subnet because it has the 2 in it. The subnet mask is always going to be 255.255.255.0, and then the DNS, we can just set this to 8.8.8.8 like we normally do. Now we can hit save, and it's going to reboot, and we will no longer be able to access the controller from this IP address because we just changed it. So if I try and refresh the page, you'll notice it's just loading. It's because this IP address doesn't go to anything anymore. We need to type in the new IP address, which is 192.168.2.100. And there we go. Now we can access the controller. This IP address also will never change because we set it to static. So the controller is standing up for itself. It's telling the router, I don't want you to pick an IP address for me. I'm going to pick this one myself. Now, if we refresh this, you'll notice that the F16 V5 disappears because it is no longer using a DHCP IP address. So now we just have to do this for the rest of our devices. I'm going to skip over the F16 V3 because it's basically the same except the interface is just slightly different since it's a bit older. For the Raspberry Pi, the router set it to 192.168.2.4. So if we open up a page and type that in, and it instantly opens Falcon Player, which is the software running on the Raspberry Pi. If this is your first time booting up Falcon Player, you'll have some other settings it'll ask you to set first because it's the first time turning it on, but I've already set some of that up already. To change the IP address, we just need to go to the status control menu and go to network. Now, we've also set this up in another video before, so it should seem familiar. We have the two interfaces. We have the Ethernet, which is ETH0, and the Wi-Fi, which is the WLAN 0. So if we wanted to, we could connect the Raspberry Pi with Wi-Fi to the router by putting in the SSID of it, and you can see mine right here, it's this, and then putting in the password. But we don't need to use Wi-Fi, we're just going to be using Ethernet for this setup. We're going to set the mode to static because we don't want to use DHCP. And now we need to pick an IP address again. So the IP address always starts with 192.168, and then we need to choose the subnet, and we know that's 2 because we set the subnet to be 2 for the Light Show network. And then we need to pick a host number. I'm going to pick 101 because it's the number after the F16 V5, so it's a number that isn't in use, and it's between 1 and 254. And then when you click the next box, Falcon Player will automatically fill it out. Just make sure it's set it up correctly. The net mask or the subnet mask is going to be 255.255.255.0 like normal. And then the gateway, which is the IP address of the router, it already figured that out too, and that is this IP address. So we can hit update interface and restart network, and it's going to ask, are you sure you want to do this because you will lose connection? We're going to hit yes. If it asks you to set up the DNS settings, you can go to the host and DNS settings and set the DNS servers manually and set it to 8.8.8.8 and 8.8.4.4. I already had this set up, so I didn't have to do it. Now, if we try and refresh the page, we won't be able to connect to it again, as you can see, since we changed that IP address. So if we type in the new one we set, 192.168.2.101, hit enter, instantly opens it again. Here we are. And once again, this IP address will no longer change. Now I've also gone and set up the F16 V3 with a static IP address, and I chose the host number 102 because that's a number that isn't in use and it's between 1 and 254. Now, if any part of this tutorial hasn't made sense so far, I really recommend going back and watching some of the other videos because I explain everything with a lot more detail, and I would in this video, but we just don't have the time for it, and I don't want to make this 3 hours long. But now here's what we have done. We have the router set up, and we have all of the devices connected to the router with static IP addresses, which is what we want, so they won't change. And now we could technically be done with this setup. If you set up the channel outputs and channel inputs on the Pixel controllers and Raspberry Pis, which I'll be showing later down the road in this series, if that was all set up, the devices could communicate. You could send Light Show data from your Raspberry Pi or your computer to your Pixel controllers. The Light Show would run, the devices would have internet, and everything would be great. However, the only problem right now is our devices, such as our phones or computers that we use to access these devices, we will not be able to connect to them from our home network. When we're setting these up, or maybe we're outside testing lights, we want to be able to access the Pixel controllers and the Raspberry Pis to run the songs, do different tests, but from the home network, you cannot do that. You would have to connect separately to the Light Show network. So you'd have to go on your phone and change from your home network to the Light Show network, either with Wi-Fi or you could hardwire it, like if you had a computer. But it is a little bit of a pain because you want to be able to access these devices from your home network. The reason you can't do this is because of something called the firewall.
Welcome to the firewall.
The Light Show router has a firewall in it, and it blocks any devices trying to get into the network from getting in. The reason why is because usually a router is connected directly into the internet, and all of the devices on the internet could reach your router, but thankfully you have a firewall and it blocks the devices from coming in. So what we need to do is go onto the Light Show router and set up something called port forwarding that would allow devices from outside the Light Show network, such as your computers or phones on your home network, to get into the network. Now, you don't have to fear of other devices from the internet getting in because the Light Show network is still protected by the home network's firewall. So I'm going to show you how you can go onto your router and set up this thing called port forwarding to allow devices from the home network to get into the Light Show network. So back on my computer that is connected to the Light Show network currently, I'm going to go and log back into the router, the light show router. So I'm going to type in the IP address 192.168.2.1. And now once you are on the light show router, you're going to want to look for something called port forwarding. Sometimes it might say single port forwarding or multiple port forwarding, or it might even be called virtual servers. For me, it's under the firewall section, and it is the virtual server setting. So I'm going to click that. It's going to ask for the password, but I have nothing set up. And then it gives you a whole bunch of different settings. So here's what we have to do. First, we're going to give this a description. And for this first one, I'm going to set it up to work for the Raspberry Pi. You have to set up a separate port forwarding for each device. So if you happen to have 10 controllers, you are going to have to set this up 10 times, but it's not too difficult. So I'm going to call this Pi, and now we are going to select the inbound port. Now you might be wondering, what is a port and how is this method going to work? Well, the way it's going to work is if we're on any of our devices on our home network, such as our phone or computer, we're going to type in the IP address of the light show router to access whatever device we're trying to get to. Now, if you had to guess, if we're using a device from our home network, would we use the IP address that is on the home network side or the light show network side of that router? I'll put funny sound effects on in the two answers and a time above my head to give you a second to guess. That is correct. It is the home network's IP address because we're already on the home network with our devices. So to access the light show router, we'd have to use the home network IP address to get to it. But instead of just typing in the IP address to access whatever device we're trying to get to, after the IP address, we're going to type a colon and then a number. This number right here is the port. Now, depending on what you set the port to, let's say if we set the Raspberry Pi to be on port 100. You would type in the IP address of the router and then a colon and then 100. That will then go to the light show router and the light show router will see it and it's going to be like, hey, this device is asking to connect to port 100. Let me see what port 100 is. Oh, that's the Raspberry Pi. And then it's going to redirect you to the Raspberry Pi and it will instantly open it up. And then we could set up another port, maybe 200, and that could be for the Pixel controller. So this time you type in the IP address of the router again, and then the port 200, which goes to the Pixel controller. So that's how this works. In the inbound port setting, that is where we put what port we want to use to get to whatever device we're trying to access. So now, what do we set this inbound port to? What numbers can we use? Well, there are lots of ports ranging from 0 to 65,000 something ports. I forget what the full number is, but these are all of the available ports in this range. Now, some of them are automatically used by other devices and are used for certain protocols, so some of them you can't use. I would recommend using any port number that is bigger than 1024, because usually above that range, the ports are open and you don't have to worry about using a specific one. So for the Pi, I'm just going to pick port 1234, and you can see it's already there because I've tried this before. Port 1234, and this is the inbound port. Now for my setup, there is another number I can type in for the inbound port. That is because on this router, I can set a range of ports to go to this Pi. So I could type in 2000, and now any port you type in that is between 1234 and 2000, that will instantly take you to the Pi. But I don't need this many ports, so I'm just going to put in 1234 again, because I only want port 1234 to go to the Pi. And then for the type, you're going to want to select TCP, not both, not UDP. You want to make sure you're using TCP. And then the private IP address. This is the goal IP address we're attempting to reach that is on the light show network. You can see it already fills out the first 3 octets. We just need to put in the host number for the device we're trying to get to. So if you remember correctly, we set up a static IP address for the Pi and the host number was 100. This is why it's important to set a static IP address, because if the IP address changed, then this would no longer work. So the goal IP address we're attempting to reach is 192.168.2.100, which is the Pi. And then where it says private port, you want to set this to 80. So I'm going to put an 80, and then we can have a range of ports go here, but we only want port 80. So make sure you put in 80, 80. Or if it's just one single port, you can't have a range, just 80. And that's all you need to do. Well, you also need to make sure to check enable and then apply changes when you're done. But you're going to pick an inbound port, which is the port we're going to be using when we type in the IP address. Set the type to TCP. Set the private IP address to the goal IP address we're attempting to reach. And then the private port to 8080. Now I'm going to set up just one more to make it really clear. And I'm going to set this one up to reach the F16 V5. So I have that set there. And now we need to pick another port, but it cannot be the same as the Pi because that one's already in use. So we're going to pick something between this range again, but that isn't in use. So to make it simple, I'll just go 4321. And we only want this port to work, so we don't need to enter a big range, just 4321 and then 4321. Set the type to TCP, and then the private IP address, the IP address we're attempting to reach. I realized I goofed up. The host for the Pi is not 100. We set it to 101, not 100. And then the host number for the F16 V5, that's what we set to 100. The IP address of the F16 V5 is 192.168.2.100. And then the private port needs to be set to 80, and we don't need a range, we only want it to be 80, so it's going to be between 80 and 80. So now that we have this all set up, I'm going to hit apply changes, and then it will save it. So now we're going to test to make sure this works. And the way we're going to do this is I'm going to go to my computer's network settings and go back to our home network. Right now we're still connected to the Light Show network. I'm going to hit disconnect and go back to our home network. So now let's try this. Remember when I said we needed to figure out what the IP address of the router is on the home network side? That's why we need it, because now we need to know what to type in. So we type in the Light Show Network's router's IP address, which is 192.168.1.8. This is the IP address of it on the home network side, and you can tell because the subnet is 1, which is our home networks. But then we're going to type a colon after it, and then we're going to type in the port. And you can see that I've tested this before. It already is trying to autofill out the port. The two ports we set up were 1234, which goes to the Pi, and 4321, which goes to the controller. So let's try 1234. Before I hit enter, I'll just show you I'm on our home network, and I'm going to hit enter. Look at that. My computer goes from the home network to the Light Show network through the Light Show network router. I'm now able to access all of this, and just to check the controller, let's change the port from 1234 to 4321. Hit enter. And we also connect to the F16 V5. And that is everything for the separate Light Show network method. Hopefully by now, you should be able to run your Light Show off of a completely separate network and not have to worry about it clogging your home network. If anything at all in this video, a simple thing or a big thing didn't make sense, please feel free to leave a comment below asking me, hey, what am I doing wrong? Why isn't this working? And I'll try to respond as soon as I can to help you and to explain it, because I do know there's lots of information packed into these videos. If you have any recommendations or tips I should do to change the tutorials up to make them easier to understand, maybe if I'm talking too fast, which I still try and talk slower, but I'm having a hard time trying to do that. Anything at all, also feel free to leave a comment for that. But I think that's going to conclude it for everything in this tutorial. Thank you very much for watching, and I'll see you in the next video.